Let us understand closure property of multiplication. Closure property of addition says that for any two integers a and b, their sum, that is a plus b, is also an integer. Same way for subtraction also, when we have two integers a and b, then their subtraction will also be an integer. Same way, closure property of multiplication says for any two integers a and b, their multiplication a multiplied by b will also be an integer, is an integer. Let us prove it. Suppose we have two integers 3 and minus 2. Let us multiply 3 and minus 2 to find out value of a multiplied by b. We have a is equal to 3, b is equal to minus 2. A multiplied by b is equal to 3 multiplied by minus 2. When 3 multiplied by 2 is 6, and when we multiply a positive integer with a negative integer, then the sign we get is minus. So a multiplied by b is minus 6. Minus 6 is an integer. So closure property of multiplication is true for two integers a and b. Let us see another example. Suppose we have minus 2 as a and b as minus 4. A and b both are integers. Let us find out a multiplied by b whether this is an integer or not. A multiplied by b will be minus 2 multiplied by minus 4. 2 multiplied by 4 is 8, and when a negative integer is multiplied by a negative integer, then the result of the multiplication will have a positive sign. So a plus b will be 8. This is also an integer. So this property is true for multiplication. That is, closure property of multiplication is true. Let us understand a different property of multiplication. Second property is commutative property. From my previous examples, I have explained that commutative property of addition for two integers a and b is that we can add these two numbers in any order. That means a plus b should be equal to b plus a, and we have proved it. For multiplication, suppose we have two integers a and b, then we need to prove that a multiplied by b should have equal value as b multiplied by a. Let us see this by an example. Suppose for a we have 3 and for b we have 5. We need to find out value of a multiplied by b. A is 3 multiplied by 5, which is equal to 15. Now we see what is the value of b multiplied by a. B is 5 multiplied by a is 3. 5 multiplied by 3 is 15. Both have same values, right? So this property is true for multiplication. That is, commutative property holds good for multiplication. Let us see another example. A multiplied by b should be equal to b multiplied by a. Let us say we have a as minus 4 and b as 6. A multiplied by b is minus 4 multiplied by 6, which is 24, and the sign what we get is negative, because we are multiplying a negative integer with a positive integer, that is minus 24. Let us see what value we get when we multiply b and a. B is 6 multiplied by minus 4. 6 multiplied by 4 is 24, and when a positive integer is multiplied by a negative integer, then we get a negative sign. 24 is equal to 24. So commutative property for multiplication is true. We can say this property is true. So we have seen two examples, two properties of multiplication. First one was closure property of multiplication, which is true, which says that for any two integers a and b, a multiplied by b will be also an integer. And the second property we saw, commutative property, which says that for any two integers a and b, value of a multiplied by b will be equal to b multiplied by a. Irrespective of in which order we multiply the integers, the value will be same.